No. So in the previous class, we were discussing about, electric field on the axial line. What is the formula for axial line? What is the formula for axial line? Axial line formula is E is equal to what? 1 by 4 pi epsilon 0 into 2 pi by r cube. This is the formula for axial line. And for equatorial line, what is the formula? E is equal to 1 by 4 pi epsilon 0 into what? Minus p by r cube. Okay. And torque formula is what? Tau is equal to Pe sin theta. These are the three formulas which we did. And what is the flux formula? Electric flux formula. Electric flux formula is what? Phi is equal to E dot
E
S,
dot delta S.
which is also equal to V into S cos theta. Now, next one is what? Gauss law. Gauss law says that phi is equal to what? Q by epsilon 0. This is Gauss law. And we have line charge density lambda is equal to what? Q by L. And the next one is sigma. Sigma is equal to Q by A. That is, this is line charge density, surface charge density, and the last one is volume charge density. Okay. So these are the three different formulas what we did in the previous class. After that, we did about the infinitely long current carrying, infinitely long conducting charge wire. So in that, the formula is what? The formula is E is equal to what? Lambda by 2 pi.
Lambda by 2 pi epsilon 0 r cap n cap.
2 pi epsilon 0, how much? R square. Yeah. So now, so this is the formula. Now next one is what? This is for the infinitely long conducting wire. The next one is what? For the sheet, the formula is E is equal to what? Sigma by 2 epsilon 0. Okay, so we'll go with the last one today. That is what? About the shell. Okay, about the shell. So in the shell, what happens now? Suppose this is the shell. So these are the charges residing on the surface of the shell. These are the charges residing on the surface of the shell. Shell means like you can think like a football, something like metallic football. Now there is no charge inside. So there are three cases here. So this is R is the capital R is the radius and small r is the vector, which is from the center to certain point R. Now there are three parts we have taken. One is inside and one is inside and one is outside. So there are three cases. So if it is inside, there are three cases. One is inside, one is on the surface, one is outside. The first case is inside the shell. So for inside the shell, what happens? There is no charge. No charge, no electric field. No charge, no electric field. So what is the formula here? Inside there is no charge, so there is no electric field. Second one, on the surface. On the surface, the formula is what? On the surface, we have the formula. What is that? Capital. That is R is the radius on the surface. Now we have the formula phi is equal to what? Q by epsilon 0. This is coming from Gauss law, and the second formula is coming from what? E dot S. So formula here is what? Surface area of the sphere is what? Surface area of the sphere is, what is the surface area of the sphere?
Sigma 4 pi r square by epsilon 0.
So the formula for surface area of the sphere is 4 pi r square. So now it will become E into what? E into 4 pi r square. Now the second, we have equation number 1, equation number 2. We are equating both of them. So the formula is E into 4 pi r square is equal to Q by epsilon 0. So next one is what? E is equal to what? E is equal to Q by 4 pi epsilon 0 into r square. Okay. So this is the formula. Okay. This is on the surface. Now the third one is outside the shell. So in that case, the same formula is same. Only in the here it will be E is equal to Q by 4 pi epsilon 0 r square, where r is greater than capital R. Is it clear, all of you? Is this clear? See, once again, there is a shell.
Yes, sir.
There are three cases. One is inside, on the surface, and outside. So inside Q is equal to 0, electric field is equal to 0. On the surface, what happens? Q is equal to phi is equal to Q by epsilon 0 and phi is equal to E dot S. The surface area is 4 pi r square. Equate both of them, you will get this one. So E is equal to 4 pi epsilon 0 r square. Outside the surface means what happens? It is outside. So where small r is greater than capital R. Clear?
Yes, sir.
Please copy this one, then we'll go to the next case. Is it done? Yes. Ismail, did you
So
understand?
almost done.
Ismail, did you understand this one? Moksha?
Yes.
No. So I will draw a graph for this, which is important maybe for one marker they can ask in the exam. Suppose this is the electric field versus distance. One is electric field versus this is R and this is small r. And the second one is what? Electric potential versus R. Now for electric field, what happens? It is 0 from the center and it is maximum here. It goes like this. Second one is for electric potential, it goes like this and comes like this. So these are the two graphs. So electric field is 0. If you take for the shell, electric field is 0 from the center to the radius. It is maximum at the on the surface, and as we are moving away, it is decreasing. Same thing will happen, but in the if you are taking electric potential, it is from the center to the surface, it is maximum. The same constant. Then as you're going away from the shell, it reduces. Clear?
Yes, sir.
Yeah.
Yes, sir.
So what's the second graph one?
This is electric field versus distance, and this is for electric potential versus distance. So from this week onwards, I will be giving you a weekly off also. Like maybe on Sunday or Friday, I will be giving off. Okay.
Okay, sir.
So going with the next chapter. So try the numericals, example questions and all. Okay. If you have any doubts, you can ask me. I'll start with the second chapter. What do you say?
Yes, sir.
Yeah, no problem, sir.
Okay, I will start. Then if you have to start solving the numericals. If you have any doubt in that one, just tell me. I'll write all the formulas quickly here. Now, these are all there.
Yes, sir.
Okay. So the first formula here, it starts from that is F is equal to what? Coulomb's law. Sorry, starts from Q is equal to any plus or minus any. Okay, that is first one. Second,
Quantization.
F is equal to 1 by 4 pi epsilon 0 into Q1, Q2 by R square. So where epsilon 0 is equal to 8.85 into 10 to the power of minus 12 Coulomb square per Newton meter square. And 1 by 4 pi epsilon 0 is equal to what? 9 into 10 to the power of 9 Newton meter square per Coulomb square. Okay, so these are the values. Next one. So here, then this is the electric field formula I write here. Third one, electric field E is equal to what? F by Q. And we have E is equal to 1 by 4 pi epsilon 0 into Q by R square. This is the next formula. Electric field, third one, that is superposition principle. F is equal to F1 is equal to F12 plus F13 plus F14 keeps on going. Fifth one, for electric field, E1 is equal to E is equal to E1 plus E2 plus E3. This is superposition principle again. Next one is electric dipole. Dipole moment P is equal to 2QA. Next is axial line E is equal to 1 by 4 pi epsilon 0 into 2P by R cube. And after that, we have eighth formula E is equal to 1 by 4 pi epsilon 0 into minus P by R cube. And ninth formula tau is equal to P cross E. Okay, then we have Gauss law of electrostatics. Here we can write phi is equal to E dot S. phi is equal to E dot S and phi is equal to Q by epsilon 0, 11th formula. So 12th formula, 13th formula, 14th formula, 15th formula, and 16th formula. E is equal to 1 Q by 4 pi epsilon 0 R square. This is the formula. These are all the formulas. Please copy these formulas and try the numericals. Okay.
Good afternoon, sir.
While downloading the question paper, team is working. While uploading is not working, right?
No, sir. Actually, it is not working.
Question paper we can download from our teams.
No, sir, I took it from Vishnu.
Where the where?
Screenshot, sir.
सर हमारे तो पेपर ही नहीं आया था हमें तो मैम ने चार्ज कर दिया
Okay. Sit down, sir.
Sir, I don't know when I open it, it's full white color.
अशाल
Ashas?
How do I open it? Yes. Very देखो तुम्हारे लिए sweet.
Okay. Okay, first let's finish off the formula. So these are the formulas. Quickly write these formulas in your notebook. It's the first. So I did that derivation for shell. Okay, the shell I completed. Yeah, shell I completed. Now we have these formulas.
सर 11 मिनट में शेल कंप्लीट
What 11 minutes? 20,
11 minutes.
18 मिनट
18 minutes. Huh? Quick.
Sir, I was about to comment one only. She took me to Puranmal. What is the Anwar flour mill? Anwar flour mill.
Okay. Okay, we are starting with the second chapter now. Okay, Dhruti, we were doing I completed the last derivation. The last derivation of this one shell, and then I wrote all the formulas. I wrote all the formulas. Those
Okay,
formulas
sir.
were completed. Okay. Now
Yes sir
I'm going with the next one. Next lesson, that is potential electric potential, electrostatic potential and capacitance. Electrostatic potential.
सर पता लगे मछली के पॉट में डाल दिया
Electrostatic potential and capacitance. Okay. So we'll start with electric potential, then potential difference. Okay. Electric. Achha, electric potential. Listen. Electric potential means what? Suppose there is a charge Q whose influence is up to a certain extent. Okay, this is the influence. Its influence is up to a certain extent. Now what we are doing is we are bringing a unit positive charge from infinity to a point under the influence of charge Q. See, once again I'm telling there is no unit positive charge. One charge is not available in the nature. Only just this is for our understanding. So we are bringing a unit positive charge from infinity to a point under the influence of charge Q. So that is said to be electric. For how much amount of work is done? For that, how much amount of work is done to bring a unit positive charge from infinity to a distance of to a distance or to a point under the influence of charge Q. That is said to be electric potential. The formula is V is equal to W by Q. Okay, V is equal to W by Q, and units of electric potential is what? Is measured in volt or capital V or joule per coulomb. These are the units of electric potential. The next concept is potential difference, electric potential difference. Potential difference. Is it clear the first definition, all of you?
Yes.
Yeah.
Yes, sir.
Okay. Now we are going with the second one. So in the second one, there is a charge q whose influence is up to a certain extent. Now we are bringing in a positive charge from point A to point B. This is point A. This is point B. We are moving a unit positive charge from point A to point B under the influence of charge q. We are moving a point charge under the from point A to point B under the influence of charge q. What is the formula here? We have VB minus VA is equal to what? WB minus
Sir, what is infinity over there?
infinity. The distance from
The distance between two charges?
from here to this influence
Oh, okay.
is infinity. Okay.
Hmm.
Now, so the formula here is what? VB minus VA is equal to what? WB minus WA by Q. Okay. So means what happens here? The work done required to bring the charge from infinity to this point is less than the work done to move the charge from here to here. Here up to here it is more. Up to here it is less. So we're just subtracting the work done. Okay. So that is said to be the potential difference. Is it clear, all of you?
Yes, sir.
So can you explain it again?
Suppose there is a charge whose influence is up to a certain extent. Now we are bringing a unit positive charge from point A to point B under the influence of charge q. So when you are moving close, the work done is more and more. As we are moving closer and closer, the work done required to move the charge will be more and more. Is it not?
Yes, sir.
So that is the difference is known as potential difference. Okay.
Yes, sir.
Now next one is what we have potential due to a point charge, the post derivation. Post derivation is potential due to.
Sir,
Yes, sir.
one thing I wanted to ask,
Yeah.
not about this topic. In Buddhism, will we get log table?
Yeah, they will be locked.
Oh,
I will show you how to use that lock table.
Yeah.
Okay, I have that. I think I have sent that lock table in that also. In the attachments. In the attachment,
Oh, in the attachments of
it is there, lock table. You can take a printout of that also.
Yes, it's way behind it.
That is there, but I have given one. You can take a photocopy also, not a problem. So I'll show you how to use that. Okay. Generally, see, whenever we have like this example, I'm just showing you. Like 2 to the power of 1 whole to the power of 13 is there. It's difficult to calculate, right?
Yeah.
So for such type of calculations, we use logarithms. Understood? Or if you want to find out root or something like that. Suppose the root of
Root is also
91, root of 351, something like that. If you want to calculate, or cube root like that, if you want to find out, we have
1 by 2
use,
log of 351.
yeah. So we have to use logarithms for this. I'll show you how to use this. Okay?
Yes.
We'll make it easy.
ये सब physics में है ना?
Chemistry,
No,
man, you can use
numerical.
for any calculations.
Yeah. Today something he asked, which
First
is,
time.
huh?
First time.
Yeah, first.
As if you have something before. Look, keep a monkey face will be sitting over here. And
कोई हंसा नहीं चुप कर
so then,
Potential due to a
what's the
point.
controlling? See, that's controlling.
That's क्यों आ गया?
थप्पड़ दे तेरे को
Super say, yeah.
That's not me. That's it. That's him.
No,
20 years back. Sorry, 17 years
Okay,
back.
okay. Control. So now,
Sir, 17 years back,
so
they were
listen, listen.
चिल्लाओ मैं?
Now,
Then
now there is
गेम
a
चला दो
same situation. Now
One,
there is
two,
a
yeah.
there is a charge q whose influence is up to a certain extent, and we are moving a unit positive charge from infinity to a point. Okay,
Yes, sir.
at a distance r. The same this situation we are using.
Okay.
So we have work done by a variable force. See, we have two formulas in grade 11. Work done by constant force and work done by variable force. Okay.
Grade 11 has physics.
So I think this air Suvidha has already started again.
Yes, so yeah. Sir, in India now 10 lakh cases.
Huh?
The new one.
No.
Yeah.
yes, yes.
In India 10 lakh
India
cases.
बहुत prices.
China full.
Yeah, is it true?
Yeah.
yes sir sorry
Sir, it came in India Times or something.
No, I. W is equal to what? F dot S. Okay. And we have work done by okay, work done by a variable force. What is the formula? Yeah, work done by variable force. What is the formula which we studied in grade 10? Can anyone say in the online?
Grade 12, I don't know what is that. 12,
इससे सारे
Sorry,
मतलब online.
finish.
Specific क्या?
Objective.
What can you repeat?
Work done by variable force. What is the formula? Work done by variable force. Anyone? Moksha.
Delta
Hey,
variable and delta.
Yeah, tell me. Anyone online? Work done by variable force, grade 11. Hey, sure. If you do you know the formula?
somewhere.
What is the formula?
W is equal to work done by variable force, no? Yeah, W is equal to Q by something.
W is equal to integration F dot
See,
dr.
W-
This is our status one.
W2.
This is for integration. This is for no. This is grade 11.
Okay.
Online.
Online.
Grade 11 online. Yeah.
11.5.
Oh,
So, you are a teacher.
no.
Oh yeah. Oh yeah.
Teacher.
Huh?
Sir, you are only a teacher.
Yeah, I was teacher. Yeah, I was teacher. Yeah.
सर F dot DS होगा ना?
DS होता है लेकिन हमने R लिया है. S की जगह R लिया है डिस्प्लेसमेंट.
Oh, okay.
Okay, same. क्योंकि मेरे पास डिनोमिनेटर में R है ना. And I'm taking this potential formula.
बनने की कोशिश कर रहा हूँ.
अंकल की जगह बैठा नहीं.
Now,
Don't
so I'm
provoke
going
me.
against the
Don't
force.
slap me.
See, I'm moving the force charge against the applied force, against the force of the charge, against the field of the charge. So I'm writing here. What is the formula for force? 1 by 4 pi minus. I'm writing here 1 by 4 pi minus. I'm writing here,
0.
because the force is against. And from where to where? Infinity to R. I'm moving from infinity to a distance R. Okay? Infinity to a distance R. So 1 by 4 pi epsilon 0 into Q1, that is Q0 divided by R square. Q0 की value कितनी है? 1 है. Is that clear? Q0 value is 1 into dr. Is it clear?
Yes.
Once again, see from the beginning, work done by constant force is W is equal to F dot S. Means suppose if I am pushing the table constantly, then the force is constant, so work done is W is equal to Fs. But work done by a variable force means, like suppose 3 people are pushing the car. One person gets a call and he leaves the car and he attends his call. So is the force constant now? No, force is not constant, right? So in that situation, you cannot apply this formula. You have to apply W is equal to integral F dot dr or F dot ds, whatever it is. Is that clear? Is that clear?
Yes, sir.
Yes, sir.
Grade
Yes, sir.
11. This is not in grade 12. This is in grade 11. W is equal to integral F dot ds. This is the formula in grade 11. Now, because the force, why I have to negative? Because I'm going against the direction of the field. I'm moving this fellow against the direction of the field. So it is minus. Is that clear? It is minus. Okay. So F dot dr. So what will happen from where to where? Infinity to R. So that's why I wrote infinity to R. Now what happened? There are two charges, right? This is Q and this is Q0. But the Q0 value is equal to what? 1. The value of unit positive charge is 1. So now I am taking all the constants outside. What is the constant now? Q0 की value 1 है. Just forget about it. Minus Q by 4 pi epsilon 0. From where to where? Infinity to R. Infinity to R. 1 by R square dr. Now, what is that? What is the integration of 1 by x square dx? Can anyone say? Math students.
1 by x square dx. 1 minute.
Yes, math students are here also in
2
our
by x square, no?
online.
2 by, sorry, 3 by x cube.
Moksha, Dhruti.
Minus x raised. No, wait, sir. Minus 1 by
Oh,
x.
no. X raised to
Dhruti,
minus
what is the
2,
formula for 1 by x square?
2 plus 1. How much is minus 2 plus
Integration.
1? Minus 1. Sir, x raised to minus 1 by
Oh my
minus
God.
2. Sir, x raised to minus 1 by minus 2.
Sir, minus 1 by x. मैम सर मैंने ये पहले ही बोल दिया था.
X raised to minus
Ma'am
1 by
means
1.
I have to wait and come then again.
Sir, x raised to minus 1, I told.
Okay, no problem. 1 by, okay, ठीक है. लड़ो मत.
Yeah.
1 by x square dx.
Clarify.
I heard it. Okay, how many times?
अच्छा, sorry.
Sir is like recognize me.
Sir, कुछ तो एक आंसर कर दिया ना.
Okay, minus 1 by x. That's a problem. You did it without. You have to remember this one. These are the format. As a math student, I'm telling you. Bio student, they don't remember. That's a different. So they don't have the minus 1 by x. So W is equal to what? W is equal to minus Q by 4 pi epsilon 0 into minus 1 by x. Okay. Minus 1 by R. From where to where? From infinity to R. Okay. So I'm erasing this part here. So you can use the same diagram for this also. You can use the same diagram. Now W is equal to what? Minus of minus will become plus Q by 4 pi epsilon 0. From where to where? From 1 by R. Upper limit minus lower limit. 1 by infinity. What is 1 by infinity, anyone? What is 1 by infinity?
1 by unknown value.
Yeah. Can anyone say what is
0.
1? Yeah, very good. Who Moksha told? Yeah, 1 by.
Yes, sir.
Yeah, 1 by infinity is 0. Very good. Now Now here 1 by infinity value is 0. Okay, is this clear of you? Non-math students. Is this clear? Now W is equal to what? We have Q into Q naught by R square. So V is equal to what? V is equal to W by. So what will happen now? The answer for this, I'll write first W. W is equal to what? Q into Q naught divided by 4 pi epsilon 0 R. Now what is V? V is equal to W by Q. So implies what? V is equal to Q by 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0 into Q by R. This is the formula for electric potential. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
So you can note down this also. You can note down this also. What is 1 by 0 value?
Not defined.
Not defined.
Very good. 1 by infinity. 1 by 0 is infinity. And 1
Lab karo na.
she told
And
before you.
who told?
Okay, please copy this. I
What do
think.
you-
But I said unknown. मैंने सही नहीं बोला.
Who told?
Correct, yeah.
मैंने बोला.
Undefined. Yeah.
No, before the meeting.
तू अपना काम कर.
Come on, get it.
मैंने से किसी और.
Second derivation. Now potential due to an electric dipole. This is very important. Okay, this came many times in exam. Electric dipole. Please stop this. I need to complete this.
That's okay.
Please stop.
pen मेरा.
I cannot keep on muting. Okay, like that. Please stop.
Yeah.
Control yourself for some more time. Now, see here, there is a dipole here. Moksha, there was nothing like that. No, I have to make this fellow quiet. That's the reason I'm unmuted. Okay. Okay.
Yeah, no problem, sir.
Otherwise, he will be troubling me.